All right. Well, today's lesson is on a type of exponential function, and I'll be more specific in a second. Notice the formula looks very familiar. We see final amount, we see initial amount. Now, what we called before growth factor, they call a split factor, because what is this split factor? Not only a fraction. You could say proper fraction. If I was really just looking for you to say 1/2, and then my follow-up to that would have been, well, because this growth factor or split factor is 1/2, what type of exponential function does that make this? It's a decay. And when the base is in between 0 and 1, it's a decay. So all of these half-life problems, you're gonna see the word half-life over and over and over again, and eventually you'll probably just want to have we're gonna get a headache from all the same problem over and over and over again. And once you've had enough, you wave the white flag, let me know, and we'll call it a day. But these are gonna seem very repetitive. The thing though is that we need to also focus here. Because yeah, we take it to the power of a time, but more so than a time, and maybe a better for the exponent, maybe a better use than saying time would be on cycles. See, like we're used to final amount depending on time. We would be like, amount is dependent on time, but it's not really time. It's how many cycles, like how many times is whatever this event that's occurring, like how many times is it occurring? We did have a few examples of that on the previous lesson, where we had to divide the time by something. Well, on all of these, we're going to have to divide it. So just know that this up here is total time that's passed by, that's elapsed, and this is the time of a half-life. You have to divide those on the exponent. Now remember, because this is a half-life, what's going to be constant? What's going to stay the same from problem to problem? Why do you think they call it half-life? What's going to stay the same on all of these problems that are half-life? The split factor, the growth factor, the base, whatever you want to call it, is always going to be 1/2. Yeah. So there's a bunch of numbers here. Look, iron 59 is used in medicine to diagnose blood circulation disorders. The half-life of iron 59 is 44.5 days. How much of a 2 milligram sample will remain after 133.5 days? So there's a lot of numbers there. What number plays absolutely no role into what we're going to get here? The 59. That's more of the name. They call it iron 59. So let's just you can call it, like on yesterday's quiz. You can you were asking me this question. You can call the function whatever you want. I don't care what letters you use. Let's just say that the amount after some time is equal to, what's the initial amount? Yeah, do you have to put all those .000s? No. So just say 2 is the original times always 1/2 to the power of, what's the total time that we're measuring? 133.5, but that needs to be divided by the duration of a half-life. How long does a half-life take? So with this, by dividing it, like if you were to ever be asked what that gives you, maybe I should even write that up here. Probably better if I write it up here. What this is going to tell you is the number of half-lives. Gotta be correct. Half-lives. I'm hoping that those two divide evenly. What is 133.5 divided by 44.5? And actually, you know what? I should probably change this. I'm sorry. Not that it's going to make a difference in your answer, but that's the amount is based on, like, we're figuring out the amount of half-lives. What is 133.5 divided? Is it like 3? Is it exactly 3? Somebody with a calculator tell me so I don't have to calculate. What is 133.5 divided by 44.5? Please, please, please. It's 3, right? Perfect. So then I can just say A at 3. Oops. A at 3 is equal to 2 times 1/2 to the 3rd power. Normally these numbers would be really sloppy, and at this point you would just plug everything into the calculator, but these numbers aren't. So I always prefer to work things out one step at a time and simplify. If I don't absolutely need to round, and these numbers don't scare me. How do you take a fraction to a power? No, one word. We've covered this. We did properties of exponents a couple weeks ago. How do you take a fraction to a power? How do you take a power of a quotient? One word. Say it again. Distribute. Good. So the amount after 3 half-lives is equal to 2 times 1 over 8. What? How'd you get 1 over 8, Mr. Romero? I don't get it. What's 1 to the 3rd power? What's 2 to the 3rd power? So the only thing I have left to do is multiply 2 times 1 over 8. This gives me a 1, this gives me a 4 if I reduce it. So the amount after 3 is 1 over 4. Now, you know what? I believe in the form of the number staying the same. So like they didn't give me any fractions here. There were decimals coming out all over the place. So I would do 1 divided by 4 is 125. So and then if they wanted, you never know on these yesterday's didn't really ask for it, but on any of these tests or quizzes you might have to contextualize your answer. So we were looking for how much of a sample will remain. We were measuring that sample in milligrams. So this would be 0.25 of a milligram. Any questions there? Yeah. Here? I took 2 to the 1/3 power, which gives me 1 over 8. This 2 ended up the initial number was hanging out the whole time. And then I just multiplied 2 times 1/8. You can do it on the calculator if you just want to jump straight to the decimal, but 2 times 1 is 2 over 8 is Gallium-68 has a half-life of 68.3 minutes. How much of a 10 milligram sample is left after 1 half-life? 2 half-lives, 3 half-lives. Ooh, come on. We're reading those. What number is not going to be used here? 68, that's obvious. That's part of the name. What other number is not going to be used here? Yeah, we have no use for 68.3. Because, yes, they tell us that a half-life takes 68.3 minutes, but then when they give us the total time, they don't give us a total time. They don't say how much is going to be left after, and then like 100 and something minutes or 200 something minutes. They say the actual amount of half-lives, and when you take total time and divide it by the time of a half-life, what do you get? Pointing at it, what do you get? Number of half-lives. Well, they're already giving us a number of half-lives. So all I need to do here, who cares about the 68.3? I need to know. Let's do each one. Let's make this look pretty. So the amount after 1 half-life, the amount after 2 half-lives, the amount after. Like here on the one before, when I divided, that was just telling me how many half-lives. How many half-lives did I have on number 1? When I divided the total time by the time of a half-life. How many half-lives did I end up with? 3. Well, now they want me to know 1, 2, and 3. So what's the original amount? 10 milligrams. They do tell us 10 milligrams, so that's going to be 10 times 1/2 to the 1 equals 10 times 1/2 to the 2. And then equals 10 times 1/2. But wait, mister, I don't get it. Where'd you get 1/2 from? Why do you keep on putting 1/2 there? I don't get it. Jason gets it, but other people don't get it. Jason, maybe you can explain. Jada, where'd I get 1/2 from? Half-life, yeah, that's going to be the growth factor, what they call the split factor. What is 1/2 to the first power? 1/2, and what's half of 10? Yeah, it's just 5, so there's no need here for any decimals or anything. And we're measuring in milligrams, so 5 milligrams. What's 1/2 to the second power? I don't have as much space, that's why I'm not writing as many steps. 1/2 to the second power is 1/4, okay, or 0.25 times 10, that should be 2.5. If you just pop that into the calculator, you should get 2.5. Geez, it's almost like if every new half-life, the amount is getting cut in half. So watch, let's get crazy without even using the formula. Without using the formula, without using your calculator. Oh, you might need your calculator for this one. I don't need it though. After another half-life, what do you think we're going to be left with? 1.25. And how could you get that without actually using the entire formula? It's half of 2.5. Yeah, every time you're just cutting it in half. Half of 5 is 2.5. Half of 2.5 is 2.25. And then you can just verify that by using that formula. Kiara, confused yet? Let me know if you are. Or talk to Brandon. He's an authority on half-lives. This one should work. If the passing of 5 half-lives leaves 25.0 milligrams of strontium 90 sample, how much was present at the beginning? So what are we looking for here? We're not here. We're looking for an initial amount. Well, in any formula, anytime you have several unknowns, anytime you're going to look for any certain unknown, they have to give you the rest of them. Normally, the one that we're looking for is the one that's isolated. But here in this formula, we're not looking for the one that's isolated. We're looking for this one here, the initial amount. Well, then they have to give us a final amount. We already know the split factor, and they tell us how many half-lives. And they do. So instead of putting A at 5, I know what A at 5 is because they told me after everything was done, what was left at the end. 25.0, which is just 25, equals this original amount that I'm looking for. You could use an A, that's fine. Times 1/2, good, to the power of? Excellent. You don't know how I got those numbers, holla. Ingrid? You know how I got all of those numbers? You gonna say something? Yeah.
Is A? No. What is it?
A is an unknown, yeah. I used an A for amount, but you could have used any letter you want. What is 1/2 to the 5th power? Maybe 1/32 if you want to get crazy. Ingrid, look, if you weren't confused enough, now I'm really going to confuse you. BAM! 1/32 times A is the same thing as saying A/32. If you want to write it as 1/32 times A, be my guest. Regardless of how you write it, the next step is going to be the same. How do you cancel out dividing by 32? Yeah, so regardless of how you write it, you end up multiplying by 32. So then all the children rejoice because the original amount was, let's see, if I have 32, is it 800? Mental math. And we're measuring in milligrams as well. Started with 800 milligrams, and after 5 half-lives, we're about to 25 milligrams. I like this one. How much of a 1.0 gram polonium-214 sample remains after 818 microseconds? The half-life of polonium-214 is 163.7 microseconds. So this is gonna be like the first one. They want to know the final amount. That's what we're looking for. And that final amount is going to depend on how many half-lives. How can we calculate the amount of half-lives? How can we calculate how many half-lives those? Divide total time is the same thing I wrote on the top of the screen, which is 818 divided by 163.7. That is going to be equal to, what's the original amount? 1. And that 1 is being multiplied. What's anything times 1? Itself. So if you want to write 1 times 1/2, be my guest. I like to live dangerously. Maybe this was like my trainer courses. I would just I would write the 1, but I'm not gonna write the 1. I believe in you. You guys know that the 1 doesn't need to be there. And that's gonna be to the power of whatever 818 divided by 163.7. Does that work out evenly, or is that's gonna give you a decimal? 818 divided by 163.7. You have to round, or is it exact? You have to round. All right, well then just put it all in the calculator at once. You know what? Let me see, because I don't trust any of you. Just kidding, I trust Ann. 818 divided by 163.7. Yeah, 4.9. They probably wanted you to round to 5. Just put 5 here. But on the other side, it won't round. That's like more or less 5 half-lives. We'll put a little rounding thing. So I'll put 0.5, that's the same as 1/2 power, parentheses, 818 divided by 163.7. So I'm getting, and it doesn't tell us where to round. Son of a gun. Okay, I'm just gonna go 0.03. And that was being measured in grams. So 0.03 grams. Which I believe is known as a centigram. And I'm not good with the metric system, but I believe that's called a centigram. Fax machine. Is that what you got also, Aaron? Marquise, is that what you got? That big machine you got? Jason, what's wrong, man? You look like you're suffering. Your head hurts? You know what I do when my head hurts? Math. Kiara too. Right? You do math when your head hurts and it makes you feel better? The initial mass of a radioisotope is 10 grams. If the radioisotope has a half-life of 2.75 years, how much remains after 4 half-lives? Ooh. You know what? You guys do this one. You can do it! Go, Jason, go. Let's go, Jason. Let's go. Nobody, Kai, no? Why? How long should it take you? Like 5 seconds, maybe 8 seconds. If not taking way too much. What piece you got it? That's not what I got. I might be doing it wrong. That's what I got. Yeah. Here, maybe this will help you. I don't know. I copied and pasted this because I thought it looked nice and it's colorful and everything. But maybe because I don't have this written in function notation, this is confusing to you. What does the final amount depend on? What is it dependent on? Number of half-lives. So like if you were to write this, the little number that goes in the parentheses, the one that you're gonna actually end up plugging in up here, is how many half-lives have passed. Well, geez, if they're nice enough to already tell you how many half-lives we've gone through, well, they don't have to work for you. So the amount after 4 half-lives is equal to the original amount, which is 10, times 1/2 to the power of 4. Who cares about this? It's just a distracting. I was just meant to put back out your face. So this is just going to be equal to 10 over 16. Watch heads explode as I figure out how I got that. And then since they're dealing in decimals, that is 0.625. 0.625, we're measuring weight in grams. So I'm not an expert on the metric system, but I believe that's 625 milligrams. If this were a science class, I'd force you to have to write it that way. If you have any questions, ask now, Ingrid. The half-life of tritium, 31H, whatever that means, is 12.3 years if 48 milligrams of tritium is released from a nuclear power plant during the course of a mishap. What mass of tritium will remain after 49.2 years? And then how much will remain after? So this is just these numbers here that are given to you in years are just to help you determine how many half-lives. Maybe skipping steps will help you. Let's try that because you don't seem to really understand this. So here we go. Let's figure out the first amount. Instead of writing it with a division, let's just go ahead and find the half-lives already. What is 49.2 divided by 12.3? Give me that right off the bat. I'm not going to write anything else. Tell me what that is. 49.2 divided by 12.3. Huh? 4. 4. So what is the first thing telling you? That they want to know the amount left after 4 half-lives. The initial amount is still 48 times 1/2 to the power of 4. On the next one, is that just what, one extra half-life? What is 98? No, it'd be 8. 98.4 divided by 12.3. 8. So how much is going to be left after 8 half-lives? 48. Not that. I mean, look. Look. As long as you write it, if you just put it straight into the calculator, I could live with it. That's the same as 48 divided by 16. I believe that's going to be 3. Is that 3? I'm doing it in my head. So 3 milligrams will be left after 50 years. That sucks. That's going to last forever. And then on the next one, I know that that's the same thing as saying 48 divided by 256, whatever that is. I think 2 to the 8th is 256. So whatever 48 over 256 is. Jason, do you know what that is? 48 divided by 256? I got 0.1875. If you got something different, let me know. Kai, you still gonna bring a calculator so you can practice putting something in the calculator? Read questions? No questions? Technetium? Technetium 104 has a half-life of 18.0 minutes. How much of a 160 gram sample remains after 90 minutes? So watch here, let's try that again, even though nobody seems to be saying anything. Before I write anything down, let's just tell me how many half-lives. That's what we want. How many? Do they tell you? Do they outright, flatly, explicitly tell you how many half-lives? No. So how could we find the amount of half-lives? It's one of the first things I told you on the screen. Divide total time by half-life time. What is 90 divided by 18? The 5. So this is what we're looking after. 5 half-lives is equal to the initial amount, 65, times 1/2 to the 5th power. I know that 1/2 to the 5th power is 32. So what's 165 divided by 32? 5.15. They don't tell me where to round. Take your word for it. Let's see if Marquis is reliable. No, you ruined it for everybody, Marquis. 5.16. And this is going to be in grams. If you don't know what we're doing, say something. Or just look at Caleb and do the opposite. Do the opposite of whatever Caleb's doing. You're like meditating. You got the same thing? Okay. Anybody know how to say that word number 8? I know how to say it. Huh? It's called manganese. It looks like magnesium. You want to say magnesium? Or manganese. Manganese 56 decays by beta emission. Have any of you guys taken chemistry? Like, what grade can you start taking chemistry at? 10th grade, you can take chemistry? Decays by beta emission and it has a half-life of 2.6 hours. How many half-lives are there? It's okay, so that's good. That's kind of what we've been doing, is first figuring out how many half-lives. So that'll work. Let's just call that H, I guess, for half-life. Half-life. What is 24 divided by 2.6? 24 divided by, it's going to be like 8 point something. 9 point. How many half-lives are there? Son of a gun. I hate this when they're rounding and then they don't tell you where they want you to round to, because that leaves like room for error. Let's just go with 9.23. That's how many half-lives there are in 24 hours. So how many milligrams of 20 milligram capsule will remain after 5 half-lives? So the amount after 9.23 hours is going to be approximately the initial amount, which is 20 times 1/2 the power of 9.23. Since we're rounding this with the wavy equal sign is 0.5 power 9.23, and depending on when you round it, and even now depending on what you round to, I'm getting approximately 0.03 of a milligram. And is that the same thing you got? Caleb, not so much. You got something different? 0.5. Ah, that's true. I got it wrong. How many? Because it didn't ask you for. Yeah, I thought it was asking you in 24 hours how much is left. Thank you. So very good. Here. Actually, want a candy bracelet? Yeah, let's erase that. I read it wrong. So it's 5 half-lives. I'm gonna have to erase everything. Just put a 5, put a 5. So that's gonna be 20 divided by 32. And hopefully there's no need to round. Point, oh, we got only 0.625. So, and we were already measuring in milligrams. So it's 0.625 milligrams. Shelby, any questions? All right, these are just more problems. The half-life of a foul-smelling substance is 4 years. Oh, that stinks. Literally, get it? It stinks. Thanks, Anne. It's 4 years. That's a long time to be smelly. If you have 8 ounces of this strange substance today, how much of it will you have after 20 years? So here, let's. Even though I'm getting little to no response from you, I have a feeling I can do a better job of driving this point home. Force you to come up with the amount of half-lives first. I'm guessing that's what we're most confused on. Yes, sir. Very good. Yes. Yes. The amount of half-lives would be the total time, which is 20 divided by 4. So that's 5. Right off to the side here. All right. So we're going for 5 half-lives. So the amount after those 5 half-lives is equal to the initial amount, which is 8 ounces, times 1/2 to the 5th power. I know that's 32, and I know 8 over 32 is 0.4, so I'm getting 0.25. You can't do it in your head, do it in your calculator. So there will be 0.25 ounces, which I think that's supposed to be, of that strange substance. And you got the same thing? We always want to check with Ann. Let's go back to letting you guys do them. Let's just go in order. I'll give you a few minutes. I know some of you are working ahead, but if you're not working ahead, somebody do number 2. Raise your hand when you got it. Show me. Show me. Mostly for you. Got an account? Oh, no, you know. Yeah, you're gonna need a calculator. Piece away. Put it away. Far, far away. Yeah, all right, you got it. Where's your calculator? Okay, Brandon. No, that's not what I got. I'm doing it wrong. Pretty sure I got it right. What did you Nope, wrong. Got one wrong. Yeah. Wait, no, I got it wrong. Why you? Because I read these too fast. She got it right. She picked up on something I didn't pick up on. Again. Brandon, let me check. You might have actually gotten it right. I gotta do it again. 0.5, 0.5. What did you get again, Brandon? And this is this one. This one's gonna be sneaky. See, the thing is here, you're gonna find the number of half-lives first. I read it quickly, and I saw the time was 70 months and 20 months, so I went 70 divided by 20. But if you paid attention to detail, what's the total time there? 20 is the total. The half-life is 70, so like you haven't even gone. This is only going through a partial half-life. The zeros cancel out, so the half-life time is 2/7. So the amount that's left after 2/7 of a half-life is equal to the original amount, which is 41 times 1/2 to the 2/7. And then you're probably just better off putting that into the calculator. You're not gonna want to waste your time with that. So 0.5 to the power of 2/7 gives me like a 0.82 number, and then times 41. So that amount after 2/7 of a half-life is approximately equal to 33.63. You don't want the candy bracelet? I don't have any more. See that SpongeBob? All right, let's see if we get the next one. Why does everybody do that? Slap it on there. Yeah, man, it's weird. So how much of the magical potion will be left after 7 years? I think this one. Raise your hand when you got it. Sube la mano, por favor. What'd you get, Reed? No. No. Look at the units. Look at the units being used. Try to get that on your calculator. On your phone. How many half-lives are we going through on number 3? 7, yeah, but wait, Mr. White, isn't it 7 over 12? Because you said that it's total time divided by half-life. Yeah, one of them is being measured in years, one of them is being measured in months. So you can either turn everything into months or turn everything into years. Normally, I would tell you to go to the smaller unit. What's smaller, months or years? Yeah, normally I would tell you that, but in this one instance, I'd probably go to the bigger one because it works out nicely. How many months are there in a year? Okay, so because the half-life happens to be exactly 1 year, how many years are there in 7 years? 7. So a half-life is just, there's 7 half-lives. So the amount after 7 half-lives is equal to the 170 that's there originally times the magic 1. You might even want to get, if you guys want to get in the habit of putting that as 0.5, because this is so calculator intensive, maybe that'll help some of you. Let's start doing it that way. Maybe that'll help you just put 0.5 there. You're going to use the calculator so much. So 0.5 to the power of 7. And that should give you approximately 1.33. We're measuring in ounces, so 1.33. Oh, oops. 1.33. The half-life of iodine 131 is approximately 8 days. Find the amount of iodine 131 left from a 35-gram sample after 32. Okay, this is a more basic one. How many half-lives here? 4, because what's the time is being measured in all days. 32 divided by 8 is 4. So the amount after 4 half-lives is equal to 35 times 0.5 to the 4th. Same thing as saying 35 divided by 16. So I'm hoping N got 2.19. And that's 2.19 grams. I'm going to finish this page and then I'm going to call it a day. This is a good one. I can already tell. I haven't even read it yet. And look at what I already spotted. And I swear I have not even read this. But what did I just pick up on? Yeah, mixed units. They're using different units. Normally I would go to, and actually watch, I will do that this time. I'm going to go to the smaller one. How many hours are there in a day? 24. So when I go to figure out how many half-lives, there's 2 days. There's a total time times 24 is 48. So it'd be 48 divided by 6. This is going to undergo 8 half-lives. So the amount after 8 half-lives is equal to the original amount, which is 500 times 0.5 to the power of 8. And I'm getting approximately 1.95. So 1.95 grams. And do you agree? Okay. Again, I haven't even read this, but I'm very careful now. And taught me to be careful. I see mixed units. When you're not sure, go to the smaller one. What's smaller, minutes or seconds? Seconds is smaller, so let's all go to seconds. Let's convert 7 minutes to seconds. How many seconds are there in 7 minutes? What? 60 seconds in 7 minutes? Oh, there's 67 seconds in 7 minutes. All right, you're gonna have to sit this one out, Caleb. You're gonna get benched for the remainder of the problem. The amount of half-lives in 7 minutes, there's 420 seconds. Well, 7 times 60 is 420. Divided by 7, that's 60. So, oh goodness, we are undergoing. This is like, does your calculator give this to you in scientific notation? 10? It's so small, it's gonna be tiny. This is undergoing 60 half-lives. That's lies. So the amount after 60 half-lives of a 50-gram sample, 50 times 0.5 power 60, yeah, it's super small. It gives it to me in scientific notation. So that's like 4.34 times 10 to the negative 17. And anytime you see this, this tells you where to move the decimal. Like if you wanted to get rid of scientific notation, that tells you where to move the decimal. So the fact that the 17 is negative means move the decimal to the left. How many spaces would I have to move the decimal to the left? 17. And the way I know when I was a kid is that once you move it above about 17 times, in every little hole, every little cup, you put a 0. You know, wherever the decimal comes to rest. But any more questions, pardon me? There's no more quizzes. I was going to give you a practice test, but I just didn't have enough information to give you a practice test. Plus, I kind of liked the review that they had available for this unit. So next week we'll do the review and the test on Thursday.